This is a video for the Talking Maths in Public animation generation collaboration for April, and the prompt this time is to create an animation that's showing a net of a polyhedron opening and closing. So I'm going to do this in GeoGebra. In fact, I've already done it and I'll run through how I did it. In GeoGebra there is a net function that will do all the work for you, but that only gives you one net, and most polyhedra, in fact probably all polyhedra, have several different ways that you can create a net. So I wanted to do something showing all the different ways that you can create a net of a cuboid. So this is the GeoGebra that I've made. I've got here open the graphics window, which has all the sliders in it, and then the 3D graphics window, which is where the polyhedron will show. And I'll just run through what I've done quickly. So if I enable this and start it, it will show all the different nets of the cuboid in order, and it will open and close each one. And I've got these width, length and sides, width, length and height sliders, which will let me change the dimensions of the cuboid as it's running. So that runs through all different 11 nets, and then when it gets to the last one it will stop and go back to the beginning. So the creation of this was quite laborious. There's lots of repetitive steps, so I'm not going to completely recreate it for you on the video. I'm going to show you the most important points, and you should be able to use that to recreate it yourself, but of course do get in touch if you have any questions or if anything isn't obvious. I've now got a blank GeoGebra window open. I'm going to start by creating my sliders for width, length and height, and we'll give these a minimum of 1 and a maximum of 5, and we'll increment them in steps of 1. You can change those if you'd rather have different values. And I want to use these sliders to create my first net. So I want to use the values of the sliders to create the first net. I'm going to change the values of the sliders so that I can see which one is which. And then I want to create some vectors that will move in different directions based on the values of the sliders. I need to translate these width, length and height, which are in 3 dimensions, into 2 dimensions for the net. And so I need vectors to move width, length and height in the x direction, and also width, length and height in the y direction. So that's what I'm going to set up, and I'm going to give them hopefully meaningful names so that I know which one's which. So let's say the width x will be moving the width in the x direction, so that is a vector, and it will go from point 0, 0 to a point width 0, and that gives me a vector that moves from 0 to 1, and if I change the value of width then that changes the length of the vector. So I can do the same for the length and the height in the x direction. And I have 3 vectors there, each of which can change as I change the sliders. And then I need to create the same things but moving in the y direction. So these will be, say, v width y is a vector, and this time it's going to go from 0, 0 to 0 width. And that creates it going up the y-axis, and again I'll do the same for the length and the height. And they all move with the sliders. So now I've got my 6 vectors and I can use those to start creating my net. I'm just going to hide them all so that they don't interfere with what I'm doing. I'm going to start by creating the first point at 0, 0. I'm going to make sure I give this point a name. I'm going to call it P1 just so that I can refer back to it later. And I'm going to make sure that the label is shown for all the new points, because I think that's going to be really useful when I'm trying to work out which points I need to move around and things like that. So starting from this point of P1, I then want to start creating by net by using the vectors to create the points for the rest of the net, and the use that to create the faces. So for my base face, let's move P1 by the width. So you can use the translate command. The object is P1 and I want to translate it by V width X, and that creates a new point there, P2. And then if I want to say the length goes along the y-axis, so let's do P3. We translate P1 by V length y, and P4 translate P2 by V length y. And then I'll make a polygon from those 4 points, and that's going to give me one face of my cuboid. Now for the next face, I'm going to keep this initial face as the base face, so this one is not going to move, but all the other ones, I want the faces to be able to rotate around the edges to close up and form the cuboid. So to do that, I'm going to create another slider, which I'm going to call closed, and this will tell me the amount that the cuboid is open or closed. So 0 will be completely open and 1 will be completely closed. So let's give that minimum value of 0, maximum value of 1, and we'll increment it by, say, 0.1. So while I'm creating my net, I want to keep that at 0 so I can see what happens on this XY plane in this graphics view. So for my next point, I'll make the face that comes up here. So this will be the height. When it closes up, this will have the height in the Z direction of the cuboid. So let's say P5 translate P3 by V height Y, but I don't want it to just be there. I want to be able to move this point when I change the value of this slider, and what it needs to do is rotate around this line that's the edge of the base polygon. So let's, as well as translating that, let's rotate it. It will need to rotate 90 degrees in total, but I want it to be a percentage of that based on the value of closed. So let's have closed times 90 degrees, and that's just, you press Alt and 0 to get the degree symbol. And I want to rotate it around the line that goes through P3 and P4. I'm going to copy that because I'm going to need it for my next point as well. So then P6 will be exactly the same thing, except you want to translate P4 instead of P3. So that's given another point there. And let's create a polygon on that for the next face of the cuboid. Now I want to test if this works, so I'm going to open up the 3D graphics view. So we won't be able to see it on the 2D. I think I'm just going to hide these axes and plane because that makes it easier to see. So in theory, when I move this closed slider, the face should rotate around that line and close up, which looks pretty good. So then I can continue in a similar way to create all the other points to make the net and rotate them around the right lines to create the full cuboid. You might find when you test it out that it rotates the wrong way, like this one does. So then you need to change your 90 degrees to a minus 90 degrees. And then that should rotate the right way and go where you expect it to go. And you can use negative vectors in the similar way, negative sign in front of the vector to translate it in the negative direction along the x-axis. For the last face, this face needs to rotate more than 90 degrees because it goes all the way around to become the top of the cuboid, so this needs to go 180 degrees instead. And minus 180 degrees. And there we have a cuboid that closes and opens. So that's my first net. I'm now going to add another slider, and this will say which, I'm going to call this net, and this will say basically which pattern of the net I'm going to use. I'm going to start it at 0 for technical reasons that I'll explain later on, and go up to 12 even though there are only 11 nets of a cube. But this is to do with the code that lets you start it and stop it and have the two sliders, the closed and the net, working and interacting with each other. So this net here I'm going to call net 1, and 0, when the slider's on 0 I want it to not show any nets at all. So for my second net I want to move this face down so that it will be here instead. So I'm going to set the visibility of this face. This is in the advanced properties, the condition to show object. So I'm only going to show this face when net equals 1. So and you also need to do all the segments as well, which is stored in GeoGebra separately for some reason. So the easiest way to do this is to change the sort by to construction order, and then when I click on this rectangle here, I can see that it's composed of all the segments that are directly above it, so they've all been created at the same time, so I know which of the segments go with it. That's the easiest way I find to select them. So if I now select all of those and set the condition to net equals 1, then that in theory, yeah, should slide them all. I'm going to leave the points there because at the end I'll just make all the points invisible completely. I don't need to show them once I've finished constructing it. So now I'll create my next face along here. So we're up to P15 now. So now we've got a different net that closes and opens to make the polygon, so I can switch between nets 1 and 2. Oh, that's the other thing I need to do, is set the condition on this new face. So we're saying that net is equal to 2. So now I can switch between the two different nets, and each one of them I can close and open. So the rest of this is now just figuring out where all the faces need to go and which faces need to be visible for each net. So I'm not going to run through all that, it takes a long time. So I'm going to jump ahead to the stage where I've finished all that process and show you the code for animating this automatically and cycling through all the nets. So now I've created all my nets for my cuboid, and I can flick through each one, and each of these I can close up into the cuboid and open out into the net. I've done a few things to tidy it up. I've made it a different colour. I've hidden everything from this graphics view. The way I've done that is if I sort by dependency, sorry, not by dependency, by object type, then I can, for example, select all the polygons, and in this advanced menu you can select where this is shown. So they are now only shown on the 3D graphics view, and similarly for the segments. And all the points I've made invisible, so you can do that by selecting them all and clicking show object, and then that will hide them all or show them all. So now I want to create my buttons that will allow me to let this animation run automatically, to cycle through all of the nets and to open and close each one. So I'm going to create 4 buttons for that. I'm going to have an enable and disable button. I'm just going to create them at the moment and not do the scripts just yet. The reason I want this is that if I want to change these sliders manually, I don't want it to automatically trigger the automatic animation, so I need to be able to turn that on and off. Let's have another one for reset to set it all back to the beginning, and then we want a button to start and a button to stop. If you want to move the buttons, you have to right click on them, because left clicking would activate the button. Let's give these buttons some sensible names as well. So I'll call this one button enable. So enable animations. Okay, and what I'm also going to create is a number that tells me if the animations are enabled or not. So I can just have a flag animations enabled, and I'll set that to 1 for now, and I will use that in my code. So I'll start with the enable and disable. So we go into the scripting, and I want this script to run. When I click the button, it's JavaScript, I'm just going to paste in what I've written and then run through it. So this GeoGebra applet allows you to read and write values that you would normally read and write through the input bar or through the user interface. So what this is saying is, if the value of the animations enabled flag that I've just created is 1, then I want to set that value to 0, so I want to turn the animations off and set the caption of the button to enable. And otherwise, so if the animation is enabled, flag is set to 0, then I want to set that value to 1 and set the caption of this button to disable. I think for these buttons to actually work, you then have to close the properties window. For some reason it doesn't seem to work when that scripting window is open. So now if I click on it, it changes the animations enabled value to 1 and changes the button caption to disable, and then when I click on it again it does the other way around, so the animations are currently disabled. So my reset button, again we want JavaScript. So this sets the values of my two sliders to to 0, so it sets them back to beginning, and it also sets the animating flag on those sliders, which is a property of the slider that tells GeoGebra if it's animating or not. It sets both of those to false and it stops all animation in the file. So if I change these to something and press the reset button, that now sets those back to 0. The start button, again change that to JavaScript. So what I want this to do is, if animations are enabled, I want it to start animating the net slider. So that's what these two lines of code here do. And then I'll put some code in a little while into the net slider so that that will automatically start the closed slider. So I'm planning to do it so that the net will increment by 1, and then that will automatically start the closed slider going from 0 to 1 and then back to 0, and then the net will increment to 2, and then the closed will go back to 1 and back to 0 again, so they'll pass the animation between them. So that's to start the animation. Then does that very similar thing for the stop animation. Just sets animating to false on both the sliders and stops the animation, which we won't be able to see that working just in a minute. So now we need to do some scripting in the sliders themselves as well. So if we look at the properties here, first of all, I was going to change it to oscillating. I will keep that oscillating. So that means that when it runs, it goes up from bottom to top and then it goes back to the bottom. And then if we go into the scripting and JavaScript, make that JavaScript. So what this script does is, if animations are enabled and the value of closed is 0, it stops the animation on the closed slider and it starts the animation on the net slider. And then I'm going to do something similar in the net slider. So this is the script for the net slider, and what I want this to do is, this script activates every time the slider is updated. So when the slider increases from, say, 0 to 1, this script will activate. So what I want it to do is, because it's just moved up to the next net, I then want it to stop animating the net slider, which is what this line here does. If it's got to the top of the net slider, so if the value is 12, there's no more nets to look at, so I'll set it back to 0 and stop the animation. Otherwise, I want to start off the closed slider, so that's what this bit does. So that will start the closed slider animating and then start the animation. So that should, in theory, allow my two sliders to interact with each other and pass off the animations between each others. So let's try that. Let's enable and start and see what happens. And there we go, so it cycles through each of the nets, and for each one of them it closes and opens it. I appreciate that this is all quite a lot of code to grasp at one time if you haven't done this before, so I will make this file available on GeoGebra. I'll put a link in the description. You can have a look through at everything it does and feel free to ask if you have any questions about how any of it works. Thank you for watching this video. I hope you found it useful. I will put links to the GeoGebra file in the description, and also information on how you can join in the Talking Maths in Public animation generation collaboration. It'll be running for at least another few months, so it would be great to see other people's videos of how they make mathematical animations. And let me know if you found it helpful. I hope you enjoyed it.